This is Daniele. So generative AI for realistic voice dubbing across languages. Or will it be you or somebody else that will speak then?
No, the main author is not here, so I'm going to be the messenger, as was previously said. Thanks for the introduction, and thanks for the interesting talk about audio that we heard today. It was actually really interesting insights. I'm not an expert myself in audio, but there's this guy, Emanuele, he's working on generative AI, so we were thinking, why not? You know, generative AI is used in many different applications, different kind of multimodal, and in multimedia we have text, for instance, large language models that can output text based on input prompts. We have video. Mostly generative AI is used in those cases for super resolution, increasing the resolution of the content. We can use it for personalization, like video and painting, as I kind of presented yesterday in my other talk. But also we have frame interpolation and other techniques that we can use in video. But I guess that all the hype in video should be also kind of transferred to audio, because audio is a really important part of adaptive streaming and multimedia in general. If we're watching a video, for instance, a soccer match, I think that I watched many times a soccer match, just the video without any like comment from the speakers, and it was not as immersive as with speakers actually describing what was happening. So we were thinking, why not doing something about this for audio? So the idea is about dubbing and having some kind of realistic voice, so kind of converting the voice and tone and all the other information that we heard from the previous talk from the original speakers and converting them into other languages. So let me just start with adaptive streaming. That's a really boring slide, but anyway, the first part is about segmentation. Here is presenting video, since video is the main, I guess, hot topic. Even in this conference, video is mainly what we're talking about. But in this case, we need to talk about audio, and the most important thing that I want to remark for this slide is the segmentation process. So we have multiple segments for different video and audio content. And that's what I need you to remember. So the reason why we want to do that is because we have a lot of content. We heard lots of discussion about UGC, user-generated content, but we have many other different content in global streaming platforms like Netflix, Prime Video, Disney Plus, and so on. Even online education platform where we can watch and learn some interesting topics. And that is mostly available in only one language, right? So why not enabling other users, maybe not speaking English, since most of the content is available in English, why not enabling other users to actually learn from this content in their native language? And current solutions for that are subtitles and synthesized voiceovers. Dubbing is also another option, not for online education content or UGC, but mostly for video and TV series. There are pros and cons, of course, like in everything. So subtitles are cost effective, which means that we can usually employ AI techniques to just do it very fast without including external people actually watching the video or listening to the audio and transcribe it to text. But that kind of distracts the viewers from the visuals, right? Because the scene, if we look at the scene and we need to look at the subtitles on the bottom row of the screen and kind of changing all the time between the scene and the text, I don't know about you, but sometimes I'm getting like some kind of headache. So that is a possible solution. In my opinion, that's not the best solution. Of course, depending on the use case. Another thing is about synthesized voiceover. So we have a third-party person kind of commenting what is going on in the scene, so describing what's happening. That's kind of a step forward, but of course that it kind of lacks emotional depth, since we are losing that kind of immersiveness. The third solution, which is not shown here, is the actual dubbing. So using external people, external like professional actors, kind of redubbing, like talking about the content like they were the real actors in a different language. Of course, that is really expensive because we need to hire actors and time consuming. So we're thinking about, we need a solution that can kind of bring this cost effectiveness of subtitles, but keeping the immersiveness of the original content. So that is what we are presenting today. So the vision, as I mentioned, we want every speaker, every part of a video to be able to deliver the speech in multiple languages, while retaining their voice, the kind of characteristics that that are important. We want the voice of the real actor, but being able to translate it into different languages. So instead of hiring actors, as I explained before, we need this kind of AI techniques to automatically translate them in different languages. And another thing, we want to integrate it directly into video streaming platform, because most of the times this is done in standalone applications, which have, of course, their effectiveness, but they are kind of external. So that would be much more effective if it was actually introduced and implemented in real streaming platforms. So the key challenges of that, it's of course not that easy. We have 4 main challenges. I would talk about the last 2 because the first 2 are kind of addressed already. So the first one is the loss of speaker identity. So if we generate dubbing voices, we don't have, as I said before, the original speaker's tone. So we are actually using other people's voice to recreate what was happening, what was being said in the original scene. We have the emotional disconnection, thinking about voiceover, since we're losing that immersiveness. And the last 2 key challenges are lip sync issues. If we think about the speech and the lip movements, we want, if we're looking at the scene, if we're seeing the people speaking, so if we're seeing the lips kind of moving, but we don't see we don't hear the audio, we don't hear any kind of content, then of course there's not the kind of experience that the user wants to have, right? And also the opposite case, if if a person is speaking, but like the lips are moving, but we're not hearing anything, or if we're hearing something and the lips are not moving, that can cause some kind of problems. The last key challenge is about continuity in video streaming, since I was talking before about segments, which is the main way that the content is being made adaptive. We have video chunks, but also audio chunks in streaming, which can cause some issues, since this is not done in a sort of sentence adaptive way. So in some cases, we have a sentence which is kind of ending, starting at the end of the first segment, for instance, and ending at the beginning of the segment after that, which means that in order to being able to correctly translate or transcribe and then generate the voice in a different language, we need to consider both segments, because without the last part of the sentence, we would actually get a correct generation of the voice. So the solution, what we're presenting today, is some kind of pipeline, some kind of architecture. We have 5 main steps. So if we start with the input audio, we have the first step, which is the background and voice extraction. So we need to extract the background and kind of then add it in the end. The importance of this is that background does not influence, of course, the translation, since we want to completely focus on the speaker's voice. So background should not play a role. And we want to guarantee that the model is able to correctly process the voice and just the voice. The second part is the emotion detection. So we want to actually being able to extract all the cues, all the characteristics of the speaker's voice, in order to then be able or tell the model to convey the same kind of emotions, if the speaker is angry, if the speaker is sad. So there is something that enhances the immersiveness. The first step is the transcription and translation. So we want, given the voice, given the content, the audio content, we want to translate it to text in order to, for the first step, to be then generated, and considering also the sentiment, the tone, the cues of the speaker's voice, which was extracted by the emotion detection module, we want to generate the final translated audio. In the end, of course, including the background content for added immersiveness. So to handle the challenges, as I said, I will be talking about the two main challenges, the two last challenges, which are currently an issue for video streaming, for adaptive video streaming in this case, are lip syncing. So the idea is that, as I mentioned before, there can be some misalignment in the way the lips are moving, in the way that the audio is being reproduced, if we translate directly the audio content from one language to another. And that can be because some languages like Spanish, like Italian, are much slower. So like to convey the same content, it takes more time than other languages like English. In this case, the solution for that will be to tell the AI, to train the AI to dynamically adjust the speech speed. And I put here up to 40% because according to literature, 40% is the maximum amount of maximum percentage that you can use as a sort of range to increase or decrease the speed while preserving naturalness, which means that the user will likely not be able to differentiate between the original translated audio and the sped up or decreased speed content up to 40%. The second challenge is about the streaming continuity, about the segment, the handling of the segments. So, and a possible solution is to be able to maybe buffer an additional chunk, so 2 audio chunks, in order to then being able to completely and accurately split the sentence and process the sentences that are, for instance, starting at the end of the segment and finishing at the beginning of the other segment. For the implementation, there are many state-of-the-art approaches. Here I just mentioned some of them. So that could be used, these models could be used in the pipeline that I presented before. Some of them are, I just mentioned some of them, Librosa Speech Brain for timbre analysis and speaker embeddings. If we want to do some emotion recognition and the kind of analysis that I explained before, we can go to, there are different methods. Also, for AI-based translation, it was mentioned before already, kind of text-to-speech translation in order to get the text from the audio. We have Whisper, Google Translate, and so on. And in the end, the speech synthesis, we have several methods, neural network-based approaches. Generative Tashtarian networks was also mentioned before. So we can go with already existing approaches, but kind of implementing them in the video streaming pipeline. Some ethical consideration, which is really important, was mentioned already before, about deepfakes. The voices could be used, could be cloned for not so ethical purposes. So we have to kind of guarantee, authenticate the voice, kind of guarantee that voice, that the content translated is actually an authentic content, that we didn't use that voice to convey other information that was not originally mentioned or originally explained in the video or in the audio. Also bias in translation, because sometimes there are some discrepancies in word-to-word translation. So the kind of idioms and the kind of ways of saying things for different languages must be taken into account. And we need to have a huge amount of data in order to account for that. For industry adoption, this could actually be integrated into existing services with a minimal overhead, because that is kind of something that we could do, parsing the content, decoding the audio, and do some kind of elaboration then at the client side. So using existing approaches that can be integrated pretty easily, I would say, given the infrastructure and all the AI models doing what we presented. And also creates some kind of new monetization opportunities because that can be used to offer personalized dubbing based on different speaker voices, based on the way that a client or a customer wants that content to be delivered. So the conclusion, traditional dubbing approaches are expensive since we need to hire professionals for that. We need to pay for the time, and it's also time consuming, takes a lot of time to reproduce the scenes, and can be inauthentic since we're using the voice of external people and not the voice of the real person talking. So this AI approach that we presented is supposed to provide authenticity, the accuracy in terms of emotions, and the way that a person is talking, and also accessibility since it enables different persons to actually enjoy the content in their native language, and it can transform the global content distribution since we can break barrier in terms of accessibility while keeping the voice of the speaker intact. So, thank you for the attention. If you have some questions, please ask.
Any question?
Not really a question, more of a comment. So you're fixing the lip sync issue by adjusting the audio, but there are products like on the market to actually fix the video to the audio. So
yeah, but that is kind of a different approach.
Yeah, I know. I'm just
saying
it's an alternative.
Yeah, it's probably going to be more expensive in terms of we need to.
It's a different trade.
Yeah, of course.
So after Netflix, we have YouTube. Next is Disney.
Great talk, thank you. Yes, I am a YouTuber and work on our AI dubbing. We have found that our users strongly dislike dubs that are sped up by as much as the 40% you proposed. It seems perhaps a little on the high side, to say the least. A sort of a different approach, I wonder if your team has tried it, is around translation adaptation, which human translators would use to sort of pick an alternate translation that results in translated audio that better matches. Have you tried using models to do that kind of timing adjustment?
No, this is actually a work in progress. I am not the, as I mentioned, there's the Emanuele is working on that. I'm more of a video guy, but yeah, definitely we're testing, we're trying many different possibilities, and if we have some like proof of concept of something working, we can maybe keep in contact.
So, sorry, me again, and it's also to respond to the mention here of the adaptation. There's a specification being developed at W3C. It's called Dubbing and Audio Description Profile of TTML. So it's how to write scripts that you can exchange between different authoring systems. And it include, one of the steps is to transcribe what's in the original language. The second step could be a translation. And the third step is exactly what you were saying, adaptation of the speech to match the time windows that you have to pronounce the same words.
Yeah.
So I would really encourage your colleague to look at the DAPT, and I can give you references.
Thank you.
And I will try to translate in German because we have to wait in the end to put the verb. So how do you manage that then?
Yeah, that can get messy. Yeah, I agree.
So I think we are done. I'm not supposed to say we are closing. So Yasser, are you doing the closing ceremony?